Hello and welcome here at the Superbooth 2019. My name is Doepfer. My company is Doepfer Musikelektronik GmbH. I wanted to show you some of our news we show here at the Superbooth 2019. Our main focus this year is on slim modules. That means we show a lot of modules with functions which are already available in the modular system, but not with such small front panels. A lot of our customers, mainly customers who play live on stage, asked to have a lot of the functions available with smaller panels. So more functions at a smaller place, and so we designed a lot of the standard modules with smaller panels. And you see here the collection of the first modules we show here at Superbooth. You see here a VCO, it's already available since a couple of months, and here are the new ones. We have the A118.2, it's a noise generator with white and colored noise, and it also has available a random source and a sample and hold. The next what we see here is a micro mixer. It is used, for example, to mix the signals coming from the VCOs and from the noise generator, which is prepared as input for the filter. What we see here, it's a 12 dB multimode filter. And the next module we see is the A132. It's a dual VCA which can be switched between a linear and exponential slope. And what we see here is a 4-fold LFO. The A145.4 has 4 LFOs behind a panel of 4 HP only. And the last module in this row is the A142. It's a dual ADSR. So what you see here in this small case is the structure of a classical synthesizer with 3 VCOs. 3 VCOs, noise generator, mixer, filter, VCA, 2 ADSRs, and LFOs for modulation. Yeah, these are the standard slim modules. What we also show new here at the Superbooth is a small module with 10 HP only, which contains a complete synthesizer voice with VCO, VCF, VCA, envelope generator, also the classical structure of a synthesizer, but it has a few additional features available which I wanted to explain. It has an additional control, it's called balance. The balance is nothing but 2 VCOs which are controlled in the opposite direction to select the input source for the VCF between the internal VCO and an external input. For this purpose we have an external input socket which can be used, for example, to connect a second VCO. But there's another important feature. We have an internal sub-octave generator, which is normal to this socket. This means as long as nothing is connected into the external input socket, the sub-octave signal is used as the second signal. This means if you operate the balance control, you move between the internal VCO signal and the sub-octave signal. And another important feature is the voltage control of the times of the envelope generator. We have a small envelope generator. It's basically an ADSR type, but with reduced features. The sustain is fixed to 50% only, and the decay and release time has only one control, so decay and release is the same, but you have an additional mode switch. You can select if it works as an attack decay, ADSR, or attack release envelope generator. And another special feature is the Cvt Input. That means we have an Cvt Input that is used to control the time of the envelope generator, and you can select by means of internal jumpers if only attack, only decay release is used, or both for CV control, and the direction. That means if the increasing CV increases or decreases the time. Well, I think we have really a lot of functions in this small module. The idea was that in virtually each setup you need a standard synthesizer voice, and for this application this is the right module. And in addition to my words, I will play a little bit around with the model so that you can see what can be done with it. Yeah. Okay, that's so much for the slim modules. I also wanted to show you a few other modules which we not really show as news here at the Superbooth. They are available already since a few weeks or a month, and these are the Polyphonic modules. I have collected the Polyphonic modules in the upper row of this case, and I will explain shortly what they all do. At the left side we see the A195. It's the Polyphonic USB MIDI CV interface. It generates gate and CV voltages for the Polyphonic modules derived either from MIDI or from USB, for example by a sequencer, or in this example by a MIDI keyboard. And then we have here the VCO. It's a quad VCO, 4 VCOs. We have the quad VCF, 4 VCFs. We have an octal VCA, and we have 2 envelope generators. Well, I want to say a few words about the basic difference between monophonic and polyphonic modules. In a monophonic module, the controls, for example, the attack of the envelope generator is used to control the parameter of one module, the attack time of one ADSR. In a polyphonic module, the control is used to control simultaneously the parameter of several modules. In this example, we have 4 envelope generators, ADSR type, and when I operate the attack time, 4 of the envelope generators are affected simultaneously. The same is valid, for example, for the frequency of the filter or the modulation depth of the filter. Whenever I move the modulation depth of the filter, the modulation depth of 4 filters is affected simultaneously. Okay, now a few words why we have an octal VCA. Well, the main reason is that in many applications you do not need only the standard VCO at the output of the audio chain, but a second VCA which can be used for velocity. The interface also features CV outputs which are controlled by velocity. This can be used to control the second VCA to obtain also the velocity feature. Okay, now I will play a few chords. I'm not a big keyboard player. On the keyboard, where you see what happens in this classical polyphonic structure. Well, what That's what you would expect from a polyphonic synth. I have here another module which I forgot to explain. It's a multiple switch. It can be used to switch simultaneously up to 8 different signals, audio signals or modulation signals, gate signals, triggers, whatever. And I use it in this example to switch the gate inputs from the MIDI interface to the outputs of a trigger sequencer. And the result is that the CVs are still controlled by my keyboard, but the triggers are coming from the trigger sequencer. So if I switch over to the trigger sequencer, you will hear that now I do not have to play any longer because the gates are coming from the trigger sequencer. Well, the trigger sequencer is now used to control the gates, and the CVs are controlled from the keyboard. Well, that's an example how I can use the polyphonic modules, not in the classical way, by forming a polyphonic synth, but to combine different sources, in this example, the gate sources coming from a trigger sequencer with the polyphonic structure where the CVs are still coming from a keyboard. It can be used also, for example, for random voltages. You can use random sources for the control voltages of the VCOs and combine them with other gate voltages. So we have a lot of possibilities which were not available so far with monophonic modules only. Okay, that's what I wanted to tell you about the polyphonic modules. Thank you for coming, and bye-bye.